Merida is like a big hot bubble, the very fast expansion of the city. We have a lot of concrete everywhere. So Merida now has a lot of problems with the increase of the surface of the city and the increase of the heat inside the city.
As Merida continues to expand, rising urban temperatures are becoming an increasing challenge to the city's livability. With growing density, the materials we build with and how their surfaces perform become crucial in shaping whether urban heat is intensified or reduced.
We love Celosia. Celosia is in our culture for a lot of time, maybe from the 1940s. We start to use a lot of Celosia. I think it's not only cultural, but it allows the air to flow, and the relationship between the inner space and the outer space is quite nice. The permeability that the Celosia allows.
Drawing from the local knowledge and context, how can ceramic evaporative cooling systems be developed and integrated into urban environments to contribute to reducing heat stress in Merida? How can low-tech fabrication methods be employed to enable easy replication within local communities? This project investigates the design and fabrication of ceramic evaporative cooling vessels and their potential as passive cooling elements to help alleviate urban heat stress in Merida. Working closely with Luis Echeverria, local Mayan archaeologist and ceramic artist, 15 terracotta blocks were produced using reclaimed clay and a traditional press molding method which is used widely in the region of Takul. After reclaiming clay from old dry scraps, the clay slipped was left to dry until it was kneadable. It was then rolled out into slabs which were pressed into the inside of the plaster mold. Once the pieces of the mold were combined, it was left to sit for 15 minutes before the pieces could be removed, revealing the form inside. By using local materials and following the craft techniques common in the area, this project hopes to produce an effective outcome that can be easily replicated in its context. Working with Luis was an exercise of knowledge sharing and passing on of techniques. Through this exchange, making became a shared language, shaped by observation, repetition, and the transfer of embodied skill. Over 4 days, 15 blocks were produced using a singular mold. Each form carries its own individual handmade character, with unique textures and subtle variations that emerge through a slow handcrafted process. Each block was left to dry for 2 to 3 days. Once the blocks were bone dried, they were ready to be fired. Over a 2-hour period, the kiln gradually increased in temperature until it reached 700 degrees. A low-temperature bisque firing allowed the clay to be fired while still maintaining many pores within its structure. The blocks were then left inside to cool slowly to prevent cracking from any sudden temperature change, after which they were carefully unloaded and packed for transportation to Merida. Blocks were submerged in water for 30 seconds and weighed to determine the amount of water absorbed. Surface temperature was measured using a thermal heat gun at consistent increments over a 2-hour period to determine the change in temperature due to evaporation. Fired terracotta is highly porous, absorbing water and slowly releasing it into the air. As this moisture evaporates, heat is gently drawn away, cooling the material and its surroundings. The results for both solid and voided blocks were successful, with both variables showing the decrease in surface temperature. Voided blocks outperformed solid blocks on all tests. These results show the potential for fired ceramic vessels to be integrated into local architecture to perform as passive methods of ceramic evaporative cooling.